Welcome back, ladies and gents, to another geometry Regents review video. This is going to be the June 2017 Geometry Common Core exam. This was a toughie. If you're preparing for your Regents, this was challenging. I remember when this was given. This is, again, the June 2017 Regents exam. These are going to be the solutions to, what are we doing? Part 1. Which are the multiple choice, part 1. Questions 1 through 12 of this exam. Before we begin, as normal, please, I know I'm getting repetitive, but please, do not take my answers and hand them in to your teacher as a homework grade. Make sure that you try the problems. This is a hard exam. You're going to find out very quickly that it is hard. Make sure that you hit that subscribe button down below and visit my website at www.nysmathregentsprep.com. Without further ado, let's get started on the June 2017 Regents exam. Here we go. So number 1 says, in the diagram below, triangle ABC is congruent to triangle DEF. Which sequence of transformations maps triangle ABC onto triangle DEF? So the first thing that we want to realize is that this triangle up here, this triangle, that triangle ABC, has a different orientation than the triangle DEF. Orientation means that it's flipped a certain way, and they're not the same, how should I explain this? They don't look in the same direction. It's probably the best I could do. So it says, which sequence of transformations would map this onto this? Well, we got to remember, it's either a translation, because it is being moved. It's being moved, and then it's being reflected over something. It's got to be reflected, because again, the orientation is changed. So that reflection is what's going to do the trick. Let's take a look at choice 1. A reflection over the x-axis followed by a translation. Right? Well, it says reflection and a translation. Let's see what it's talking about. It says reflection over the x-axis. That's that horizontal axis that you see here. So it says a reflection over the x-axis followed by a translation that way. Well, the problem is this triangle is not the same orientation as this. This is upside down. So choice 1 can't work. Let's go on to choice 2. A reflection over the y-axis followed by a translation. So the y-axis is the vertical axis that you see right up here. And if we were to reflect it over this axis, this is what it produces. Produces that triangle. And then if we translate it downwards, yes, that's a proper mapping. So that's going to be choice 2. Choices 3 and 4 all show a rotation, then followed by a translation. A rotation in this case of 180 can't work, then followed by a translation. That can't happen. A counterclockwise rotation of 90 degrees, it means it's going in this direction, and then followed by a translation. Again, that can't work because the orientation is not the same. All right, so for number 1, it's choice 2. Moving along. On the set of axes below, the vertices of triangle PQR have these coordinates. Okay, what is the area of triangle PQR? So here's the thing that I tell students about this question. There are 2 ways that you could do this question. The first way is to actually take a rectangle, and box this in, find the area of the entire rectangle, then what you're going to do is you are going to subtract the little triangles that are bordering the main triangle, subtract those areas away from the rectangular area, and you'll get the resulting figure inside. That's a good way, absolutely. But in my opinion, the best way to do this question is to determine whether or not this is a right triangle. And the reason why is this. If it is a right triangle, you could use the following formula. Area equals 1/2 base times the height. You've been seeing that since elementary school, folks. So what I could tell you is that PQ is probably perpendicular to RQ. We have to verify that right now. So let's go ahead and do that. How do we verify perpendicular lines? Negative reciprocal slopes. All right, so what we're going to do is we're going to take the slope of PQ and take the slope of RQ and see what it results in. So the slope of line of line PQ is the following. Well, the slope formula is y2 minus y1 over x2 minus x1. And the slope, let's see here, point P and Q. So we got 7 minus 1 over negative 6 minus 2. That gives me 6 over negative 8. Let's just leave it just like that. And let's take the slope of RQ, which is, again, y2 minus y1 over x2 minus x1. That is going to be negative 3 minus 1 over negative 1 minus 2. That is going to be negative 4 over negative 3, which is just 4/3. Okay, so 4/3, here it is. This 6/8 can reduce to negative 3/4 because it just has that common factor of 2. We could just take out 2. So these are negative reciprocal slopes. Perfect. That means that PQ is perpendicular to RQ. That means we could use this formula right here. So let's go ahead and use what we know. Well, the first things first is we got to figure out the distance of PQ and RQ. PQ in this case is your height and RQ is your base, or vice versa. It doesn't really matter. So what we're going to do is we're going to use the distance formula. I'm going to erase this just to give myself some more room. Okay, and I'm going to take the distance of PQ. So let's go ahead and do that. The distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Pretty simple. So now, let's just go ahead and take those coordinates and just plug them in. So we get negative 6 minus 2 quantity squared plus 7 minus 1 quantity squared. D is equal to the square root of negative 6 minus 2 is negative 8 quantity squared. 7 minus 1 is 6 quantity squared. D is equal to the square root. Negative 8 squared is 64. 6 squared is 36. D is equal to the square root of 100, which is equal to the number 10. Okay, so now let's go ahead and find the distance of RQ. Let's do it. So the distance of RQ, let's figure it out. D is equal to the square root. Let me zoom in here. D is equal to the square root of 2 minus a negative 1. By the way, I'm just getting these numerical values from the coordinates, plus 1 minus a negative 3 quantity squared. 2 minus a negative 1 gives you a positive 3, so that's going to be 3 squared, plus 1 minus a negative 3, that gives you a positive 4 squared. D is equal to the square root. 3 squared is 9. 4 squared is 16. This is the square root of 25, which is equal to the number 5. So now, we take these two values, the 10 and the 5, and we're going to plug them into our area formula. Area equals 1/2. The base is 5. The height is 10. Area equals. Since multiplication is commutative, I'm actually just going to multiply these two numbers first because it's easier. So we're just taking 1/2 times 50, which the area in this case is the number 25, which is going to be choice 3. Definitely not a complicated question, but it was a tedious question. Okay, moving on to number 3. In right triangle ABC, the measure of angle C is 90 degrees. If the cosine of B is 5/13, which function also equals 5/13? Ladies and gentlemen, this is a very simple question if you know your facts. The sine of A is equal to the cosine of B. Make sure that you know it. This is an important formula for the geometry regions because it is on every single test. So make sure you know it. So if the cosine of B is 5/13, sine of A is also 5/13. Pretty simple. That's going to be choice 3. Moving on. Number 4, in the diagram below, the measure of arc ABC is 268 degrees. So this arc right here, arc ABC, is 268 degrees. Well, before we begin the question, let's find out what the measure of arc AC is. Well, there's 360 degrees in a circle. So what we're going to do is just take 360 degrees minus the 268 degrees. That gives you a result of 92 degrees. So the measure of arc AC is 92 degrees. Perfect. Let's read the question. What is the number of degrees in the measure of angle ABC? So we're trying to solve for this angle. Okay. Well, the measure of angle ABC is 1/2 of the length of the arc it intercepts. Let me explain why. Angle ABC, in this case, is inscribed. An inscribed angle of a circle means that the angle itself touches the circle at one point. A central angle, on the other hand, let's just say this was the center of the circle. A central angle will look something like this. Okay? We're working with an inscribed angle, though. So an inscribed angle is 1/2 the arc it intercepts. So all we need to do is just say the measure of angle ABC is equal to 1/2 of the 92 degrees. Well, 1/2 of 92 is just 46. Oop, choice 4. Done. Moving on. Number 5. Okay, given triangle MRO shown below with trapezoid PTRO, the MR is 9, MP is 2, PO is 4. What is the length of TR? Okay, so what we need to do is we need to find a relationship between these two triangles to set something in proportion. But why am I setting it in proportion? They never told us that these two triangles are similar, and we all know that in order to set up a proportion, the triangles need to be similar. The key word here, folks, even if you missed it, that's okay, but if you're really paying attention, it said trapezoid PTRO. If you didn't know, a trapezoid has parallel bases, okay? What that means is this angle is congruent to this angle, and this angle is congruent to this angle. So triangle MPT is similar to triangle MOR, so the small one to the big one, by angle similarity so far. That means that we could set up a proportion. Let's do it right now. So I want to solve for TR. That is the goal, to solve for TR, which is right here. Oh, I don't like that color. TR. Okay, trying to solve for that. So what we're going to do is I want to say this. Well, there's actually two ways that you can solve this proportion. You could either call MTX and subtract the difference, or I could show you another way right after this. So in order to solve for X in this case, we're going to solve for MT first, then subtract it away to get TR. But in order to do that, you need to add these two sides up to get a length of 6. Or 6, I should say. Why? Because 6 is in proportion to the whole length of 9. You have to add that side to get the proportion of the other side. So what we're going to do is set up our proportion. 2 is to 6 as X is to 9. Remember, that is small to big, small to big. Okay, let's cross multiply and solve. So 2 times 9 is 18. X times 6 is 6X. Divide by 6 on both sides. X is equal to the number 3. But folks, remember what we just found. We did not solve for TR. We just solved for the length of MT. So MT is 3. So TR is really the big side, which is 9 minus the 3. Your answer is 6. So that's why it's going to be choice 4. Let's just say you didn't want to do it that way. That's perfectly fine. That's one way. Let's do it another. Okay. The other way to do it is to say, okay, I'm going to say 4 is to the length of 6 again, as now just y is to 9. You could do that. That's perfectly fine. So I could just go right for TR and just get y. So we could again do 4 over 6 equals y over 9. The reason why, small to big, and 4 and the y are corresponding to each other. So now I'm just going to cross multiply. 9 times 4, that's going to be 36, is equal to 6y. Divide by 6 on both sides. Y is equal to 6. Less steps, but you get the same results anyway. Your answer is choice 4. Moving along. Number 6. A line segment is dilated by a scale factor of 2, centered at a point not on the line segment. Which statement regarding the relationship between the given line segment and its image is true? Okay. Scale factor. Scale factor is a dilation. You're performing a dilation. And under a dilation, the following is true. Dilations preserve parallelism. What do I mean by that? It means that lines remain parallel to itself no matter how large they get. So what we're looking at here is parallel. Okay. The line segments are perpendicular. No. The line segments are perpendicular. No. These two guys are in the running because they both say parallel. Now we're just looking for the lengths. A line segment is dilated by a scale factor of 2. 2 means double. Line segments is parallel, and the image is twice the length of the given line segment. Bingo. Choice 3 is your answer. Choice 4 shows that a dilation with a scale factor of 1/2, not 2. Okay, number 7. Which figure always has exactly 4 lines of reflection that map the figure onto itself? In other words, which of the following shapes has 4 lines of reflection? All right, let's draw a square. Choice 1 shows a square. Can I draw 4 lines of reflection in this square? Well, let's see. I have one horizontally down the middle. I have another one that's vertical, like that. Then I have one down the main diagonal, down one diagonal, like so. And I have another one in the other direction. Boom. Done. Choice 1. Move on. Number 8. Okay. In the diagram below of circle O, chord DF bisects chord BC at E. All right, hold on a second. DF bisects chord BC. So BC is the one that's being bisected. So CE is congruent to EB. If BC is 12, okay, so it's telling you that the length of the whole thing is 12. That means that each piece is 1/2 of itself. So that means it's 6 and 6. If the whole thing's 12 and you got to split it evenly, 12 divided by 2, 6. 6 for both. And okay, that you got to remember your algebra skills, folks. FE is 5 more than DE. FE is 5 more than DE. So DE is X and FE is X plus 5. Find length of FE. All right, let's do it. So, you should have learned some circle relationship. If 2 chords intersect each other, there is a simple formula that you should know. Part times part equals part times part. Pretty simple. As in, CE is a part, EB is a part, DE is a part, and EF is a part. Great. So what I'm going to do, plug it into my formula. Part times part. 6 and 6 equals X and X plus 5. They have to be, the parts next to each other, they have to be the same chord. You can't go 6 times X equals 6 times X plus 5. Can't work like that. It has to be on the same chord. All right, let's do it. 6 times 6 is 36. We distribute that X. We get X squared plus 5X. Move that 36 to this side. I can move it over here. We get X squared plus 5X minus 36 is equal to 0. Ladies and gentlemen, you need to know how to factor. Remember the order of factoring. It's the greatest common factor, followed by the difference of 2 perfect squares, and followed by the trinomial method. GCF and dots are out. They make no sense. This is a trinomial. So we have to use a trinomial method. So you got to think to yourself, what adds to positive 5 and multiplies to give you negative 36? Well, those two answers are X plus 9, and X minus 4. Because 9 times a negative 4 gives you a negative 36, and 9 plus a negative 4 gives you a positive 5. We're going to set this equal to 0. We're going to solve. X minus 9 equals 0. We're going to add that 9 on both sides. X is equal to 9. We get X minus 4 equals 0. We're going to add that 4 on both sides. We get X is equal to... Sorry, something's wrong here. Oh, my apologies. It's not X minus 9. It's X plus 9. Pfft. Derp. X minus 9 equals... No, plus 9 equals 0. Subtract the 9 on both sides. X is equal to negative 9. My apologies. And X is equal to 4. Now, in algebra, you used to keep both answers. But since we are in geometry, you reject the negative 9. Why? Because you can never have a negative measurement. Can't happen. Okay. So now what happens here is DE. DE is X, which is 4. That means the length of FE is equal to X plus 5. Take that X value, which is 4, plug it in. You get 4 plus 5, which is 9. That was the tricky part of that question. You had to realize that you were not solving for X and then getting the answer of 4. You have to plug it into the formula that you got, and you get choice 2, which is 9. All right, moving on to the next question. Number 9. Kelly is completing a proof based on the figure below. Okay? She was given that angle A is congruent to angle EDF. Okay, so angle A is congruent to angle EDF, right there. And she has already proven that AB is congruent to DE. Okay? Which pair of corresponding parts of triangle congruency method would not prove triangle ABC congruent to triangle DEF? Let's take a look, folks. So, first and foremost, notice how DB is reflexive. Reflexive means that it's shared between both triangles, and this is really the addition postulate. This is the addition postulate. Oops. Postulate. The reason why is that AD could be congruent to BE and DB is reflexive, and then you just add those two together. But besides the point, let's take a look at the answer choices. Choice 1 says that AC is congruent to DF, and it's by side angle side. Yeah, that's true. Side angle side. Side angle. Yeah, that works. So that's true. We're looking for the one that's not true. Okay? So that works. BC and EF. BC, right over here, and EF by side angle side. Let's see. Side angle. Side angle. Folks, what is that? Uh-oh. That's ass. No asses in geometry class. Your answer is choice 2. That side angle side should say angle side, but we know that's not a proper way to prove two triangles congruent, so it's got to be choice 2. All right, moving on, number 10. This one was not tricky, but it was tedious. Again, most of these questions were tedious. They weren't difficult until later in the exam. You'll see. Number 10, in the diagram below, DE divides AB and AC proportionally. That means, folks, this means that triangle ADE is similar to triangle ABC. Triangle ABC. So the measure of angle DFB is what? So we're trying to find DFB. Go the right way. DFB. We're trying to solve for that angle over there. So we have all this information at our disposal. We just got to figure out what is what. So I just said that these two triangles are similar. That means, folks, that this angle is congruent to this angle because DE is parallel to BC because they're similar triangles. So this angle over here is 26 degrees. Well, we can now find this angle over here because if you look carefully, this is a triangle, right? So we could solve for that angle, that red angle right over here. Well, we just take 180 degrees that's in a triangle minus 82 degrees minus the 26 degrees. Okay, well, that gives us 72 degrees. Great, 72 degrees. Perfect. So now what we got to do is we got to look a little closer. We got to zoom in our eyeballs way over here. Way over here. What is this, folks? What is that? That is a linear pair. A linear pair, meaning that this is a straight line equaling 180 degrees. So if we solve for the angle next to the 72, this means that this angle over here is going to be 108 degrees. Pretty simple so far? Okay. So now what we're going to do is, let's see, what do we do from here? Okay, let's talk about this for a second. It says that DF bisects angle BDE. That means that this little ray that you see right here, this DF right there, cuts that angle in half. So we just now need to take 108 degrees and divide it by 2. That gives you an angle measure of 54 degrees. So this angle is 54, and this angle is 54. Okay, what do we do from here? Well, again, these two triangles are similar, and they have the same angle measures. Not necessarily congruent, but they have the same angle measures. Take a look here. If this is 72, this angle down here is 72 degrees. Now that we've solved all this information, let's go ahead and find our angle. So I'm going to erase all this garbage just so you know where we're at, because I do admit that this is a lot of writing. Let me just simplify it for you. We're trying to solve for this angle right here. We found this to be 54 degrees, and we found this to be 72. This is a little baby triangle. Take 180 minus the 54 minus the 72, and you get your answer. So let's do it right now. We get 180 degrees minus the 72 degrees minus the 54 degrees, and we get a final answer of 54 degrees. Sweet. Choice 2. And it just so happens that this triangle, this little triangle in here, is isosceles. Just to throw it out there. All right, number 11, almost there. Oh, God. Oh, dear. I remember when this question was on the... I'll never forget the day that I was in school looking at this exam. It drove me nuts. Let me read it to you. Which set of statements would describe a parallelogram that could always be classified as a rhombus? Okay, let's talk about a rhombus first. A rhombus, by definition, has all these properties. I'm not going to write them all down. I'm just going to say it to you. Their diagonals are perpendicular. They're opposite. All four sides are congruent. Those are the special properties of a rhombus, okay? The other properties that you're thinking of, like opposite sides are parallel, opposite sides are congruent, diagonals bisexual, those are all parallelogram properties. We're looking for the one that specifically proves the rhombus. Diagonals are perpendicular bisectors of each other. Is that true in a rhombus? Absolutely it is. Because I just said to you that the diagonals are perpendicular because they form right angles, because in a rhombus they form four congruent right triangles, and bisectors, yeah, because this is the property of the parallelogram, and the perpendicular part is specifically for the rhombus. So that's true. That will always prove a rhombus. Let's take a look at choice 2. Diagonals bisect the angles from which they are drawn. Basically what it's saying is if you take a parallelogram like so and you make it a rhombus, the diagonals, what they're saying, the diagonals bisect the angles here. So they're saying that this angle is congruent to this angle is congruent to this angle, so on and so forth. And that is true to prove a rhombus. Absolutely true. That is specific to the rhombus. Perfect. Oh dear. Choice 3, or option 3, bothered me a lot. Diagonals form four congruent isosceles right triangles. That key word there was 4. Let me explain why this does define the property of a rhombus. And by the way, the answer is choice 4. And if you got choice 1, I will explain why you're wrong. Okay, here we go. So diagonals form four congruent isosceles right. Okay, right triangles. Well, we know that because a rhombus forms 4 right angles. Perfect. The problem that I had with this is it should have said diagonals form 2 pairs of 2 congruent isosceles right triangles. Because if you look more closely, this triangle is congruent to this triangle. Sorry, I should take that back. It shouldn't say right triangles, in my opinion. It should have just left it as 2 pairs of 2 congruent isosceles triangles. So these 2 triangles are congruent, and then these triangles are congruent. I know that's a lot of drawing, but basically, it is this triangle congruent to this triangle right there, and then this triangle is congruent to this triangle there. The problem is it doesn't say that. It says diagonals form 4 congruent isosceles right triangles. So they're saying to you that this triangle is congruent to this triangle, which is congruent to this triangle, which is congruent to this triangle. But ladies and gentlemen, that is so not true in this drawing. Why? Because we know that a rhombus's diagonals are not congruent. Yeah, we know that these sides are congruent, but the problem is we aren't sure as to whether or not this is congruent to this. We don't know that in a rhombus because they never are. The diagonals are not congruent in a rhombus. It's congruent in a rectangle. So why is that the answer? This is what got me really, really pissed off. Ladies and gentlemen, choice 3 is the property of a square. A square has this property, but by definition, a square is a rhombus, which is a parallelogram. So that's why it's choice 4. I know, I get it. It's a BS question in my opinion, but a square is by definition a rhombus. That's why it's going to be choice 4. Sorry if that hurt your self-esteem. Number 12. This is on every Regents completing the square. This is the final question of the video. The equation of a circle is x squared plus y squared minus 12y plus 20 equals 0. What are the coordinates of the center and the length of the radius of the circle? Okay, here we go. Your goal is to keep the letters on one side, numbers on the other side. So I'm going to say x squared plus y squared minus 12y is equal to negative 20. I move that 20 over to this side. Remember, again, letters on one side, numbers on the other. Now what we got to do is we have to actually complete the square, which means wherever you see a constant variable, meaning it's just y or x, just by itself, not any of the square business, just a constant, you have to insert a blank space immediately following that constant term in order to acquire a perfect square trinomial. So what we're going to do is we're going to figure out, how do we get that blank space and what's in there? Well, you need to remember back from Algebra 1 that the formula b divided by 2 squared will come in very handy to solve that. So, in other words, it's just taking half of the middle term and squaring it. We're looking at this right here, folks. The middle term is negative 12 divided by 2 and square it. Negative 12 divided by 2 is negative 6. Negative 6 squared is positive 36. So I'm going to insert that into my blank space once I get rid of all this red marking stuff. Plus 36. Boom. Now what we're going to do is we are going to factor this. That's the next step that people get tripped up on. You get this, but then you get stuck. You have to factor this now by using, again, the trinomial method. What adds to negative 12 and multiplies to give you 36. In completing the square, you always get the same factor. I'll show you what I mean. What adds to negative 12 multiplies to give you 36? Your factors are y minus 6 and y minus 6. It's the same factor. That x squared carries along for the ride. By the way, if you're wondering why didn't we complete the square for x squared? Because there's no linear term. There's no x times a number. It's none of that. So we just have to keep moving with the y. Equals negative 20. Now from here, you could actually rewrite this, y minus 6 as y minus 6 squared. X squared carries along for the ride equals negative 20. Ladies and gentlemen, this is your center. Oh boy. I made a big boo-boo. I apologize. I was supposed to add the 36 on both sides because, again, what you do to one side, you must do to the other side. Forgive me for doing that. That should be positive 16. Negative 20 plus 36 is positive 16. That's better. Perfect. So now we just have to find the center and the radius. Well, the center is just the opposite of what you see here. Well, since there's nothing on the x, it's just 0. And the opposite of negative 6 is positive 6. And the square root of 16 is equal to the number 4. So we're looking for the center of 0, 6, and a radius of 4. That's going to be choice 1 for that question. All right, that does it for this video. I hope that it helped you. Make sure to hit that subscribe button down below and visit my website at www.nysmathreadersprep.com for a lot more math content in geometry and future math subjects. And I hope to see you soon.